is called Angles and Their Measure. And I think that's the exact same title as we started in 5.1 in the Brown book. Okay, but like I said before, we did everything in that book based in degrees. And now we're going to switch and talk about something called a radian. So a radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius of the circle. So what happens now is the radian would be the same thing as if the radius is equal to the length of the arc. So one revolution around the circle with a radius of r corresponds to an angle of 2 pi radian. All this means is if I start here, I go all the way around my circle and back around again. How many degrees is that normally? 360. So now we're saying that there's a new unit of measurement we're going to use, and it's 1 complete circle. So what's it called when you go all the way around a circle? Circumference, right? So if my r is 1, what's my circumference? What's the formula for circumference? Pi times diameter, or 2 pi r. So if my r is 1, what's the circumference? 2 pi. So all the way around this circle is 2 pi. So 360 equals 2 pi. 360 is in degrees, 2 pi is in radians, okay? You can also see numbers without the pi used here. So from 0 all the way around, again, would be the same thing as saying 2 times what we approximate pi to be, which is 3.14. And that means all the way around my circle is actually 6.28. So if you go all the way around the circle, in degrees it's 360, in radians in terms of pi it's 2 pi, and in radians without pi it's 6.28. So all the way around your circle is 6.28. Halfway in degrees is 180. In radians, it's half of 2 pi, which would be pi. And in radians, without terms of pi, it would be the value of pi, which is 3.14. That's halfway. So we're going to start to build something called a unit circle, okay? And a unit circle is a circle with a radius of 1. So as I move all the way around this circle, I can fill in all the information that we filled in with degrees. I can now also fill it in with radians. So if you think about at the top, our degree here was 90 degrees. In terms of radians of pi, it's pi over 2 because it's half that pi. And at the bottom, it's 270, and it's 1 1/2 pi, or 3 pi over 2. So those are just our quadrant angles. We're going to dig a little deeper into this in 6.3, but just to kind of get an idea of what they would look like. So 1 complete revolution is 2 pi. Halfway would be pi. 1/4 of the way would be pi over 2. And 3/4 of the way would be 1 1/2 pi, or 3 pi over 2. All right, coterminal angles we found in degrees. If you remember in degrees, how did we find a coterminal angle? Add and subtract 360. So now we're saying the equivalent to 360 is 2 pi, right? So if it's in radians, to find a coterminal, we add and subtract 2 pi. So 360 in degrees is the same as 2 pi in radians. So here are some examples for coterminal. It just says find a coterminal angle 2, 17 pi over 6. And we're actually going to find 1 positive and 1 negative, just like we did with our degrees. So if I want to find a positive coterminal angle, I can add 2 pi. I have to give it a like denominator, so this becomes 6 or 12 pi over 6. And I get 17 pi over 6 plus 12 pi over 6. And I get 29 pi over 6. If I want to find a negative coterminal angle, I'm going to get 17 pi over 6, and I'm going to subtract 2 pi, which we already said is 12 pi over 6. I get 5 pi over 6. Is that a negative coterminal angle? No, that's actually a positive coterminal angle, so it could have worked for the first question, okay? How do I find a negative? Subtract it again. So 5 pi over 6 minus 12 pi over 6, and I get negative 7 pi over 6. So if it says the smallest possible angle, then I want 5 pi over 6 and negative 7 pi over 6. But 29 pi over 6 is still a positive coterminal angle. So just pay attention to directions. It might say what's the smallest value. It might say give an angle in between 0 and 2 pi, and so you'd have to give those. All right, so how do I find it with 2? How do I find a positive one? Add 2 pi. So this would become times 3 and times 3. This would be negative 4 pi over 3 plus 6 pi over 3. And I'd get 2 pi over 3. That's a positive coterminal. And then to get a negative one, negative 4 pi over 3 minus 6 pi over 3. And I get negative 10 pi over 3. Good so far?
So it's like the first chapter of the last book, except with
In terms of...
pi instead.
Exactly.
For the other one, for the positive coterminal, it could also be 29 pi over 6.
Yeah, because it didn't indicate it needed to be the smallest value or it needed to be in between negative 2 pi and positive 2 pi, either answer there would have worked. If it specifically says what's the smallest value of 1, then you're looking at 5 pi over 6. Or if it said from negative 2 pi to positive 2 pi, you want that range to be in there, then it would have to also be those. All right, converting from degrees to radians or vice versa. So if my angle is in degrees and I want to convert it to radians, I multiply times pi over 180. If it's in radians and I want to convert it to degrees, I multiply it times 180 over pi. Now, for some of these questions, the confusing part is to determine what it is in the beginning. If it has a degree symbol, then it's in degrees. It does not have to have a pi symbol to be in radians. It just won't have a degree symbol. So if you saw something like 2.3 without a degree symbol, that's actually in radians.
So the only way to determine if it's a degree or radians is if there's a degree.
Correct. All right, so this one says convert. It should say convert the angle. I'm like, what's end? Convert the angle from degrees to radians or vice versa. So if I look at number 3, is this in degrees or radians? Degrees. So I multiply times pi over 180 to get it into radians. This kind of question is going to be kept exact, so you don't use a calculator here. Okay? So I want to simplify as much as I can. I can go 5 into this 27 times. I can go 5 into this 36 times. Can I reduce those again? 27 and 36, yeah, by what? 9 can go 3 and 4. And I get 3 pi over 4. So without a calculator, it stays like that. Your quiz, the answer would stay just like that. If you're in front of me, obviously you can write that on a piece of paper. If you're at home, this answer's fill in the blank. You write it as 3 pi for pi / 4. So this would be the Canvas quiz answer. Okay, 4 degrees or radians. Degrees, so I multiply times pi over 180. Cancel through the zeros. What goes into both 54 and 18? 18, 3, 1, and I get 3 pi. And again, on a Canvas quiz, you would type that in as 3 pi. All right, number 5, 45 degrees. I just said it right. Degrees. Times pi over 180. What goes into both 45 and 180? 45. Once. 4 times pi over 4. Or pi / 4 would be the Canvas quiz. So the WebAssign and like a normal answer would be the one that's circled. If you're answering this on the Canvas quiz, obviously, and it's fill in the blank, then it's the pi over 4. All right, number 6, in degrees again, multiply it times pi over 180. How do I simplify this? Good. So pi over 2, this was that angle that was at the top, remember?
If you just memorize like the quadrant.
That's fine. Yeah. It will help you in the long run. All right, 7 says 5 pi over 6. So is this in radians or degrees? Radians. This time I'm going to multiply times 180 over pi. My pi's cancel. 6 goes into 180 30 times. And I get 5 times 30, which is 150 degrees. So on the answers for WebAssign, let me see. The little degrees already there. You just have to type the value in. And the same thing will happen in Canvas. You won't have to give the degree symbol. You'll just give the value. Number 8, 3 pi over 4, again radians. So I would multiply times 180 over pi. The pi's are going to cancel. 4 goes into 180, 45 times. And then I get 3 times 45, 135 degrees. Still good? All right. 9, negative pi over 2. What's one way to do it? Times 180 over pi. Pi is canceled. 2 goes into 180 90 times. I get negative 90. The other way is that's going to be a quadrant angle. So you can get to know it. Yep. Just don't forget your negative. Questions so far? Okay, so is 10 in radians or degrees? It's in radians, so I have to multiply times 180 over pi. So without a calculator, I would just multiply that out. I'd get 900 over pi. On WebAssign, it's actually going to say to convert the radian measure to degree and then round to 3 decimal places. So here you'll actually want to use your calculator because you'll want to use the pi button, okay? So I would just do 900 divided by pi, and I get 286.4788. So this is going to bump this up, and I'd get 286.479. So you will not have your calculator or the lockdown calculator on the quiz. That kind of question won't happen on the quiz, but you will see it in the homework. If it was on the quiz, you would have left it like this. All right, 11 degrees or radians? Radians. So I multiply times 180 over pi. I'd get 360 over pi. 360 divided by pi. 114.592 degrees. Everybody still good? Okay, so the other thing that's going to happen with these is you're actually going to be asked to draw them out. So if I'm going to graph these, okay, then I want you to start thinking about what this circle looks like. So obviously, hey.
Is this the same circle we used for last?
Yeah. Except that, remember, each of those corners have a degree measurement. And now they've got a radian. So there's two different kinds of radians. The 0 obviously stays the same. But this is pi over 2. This is pi. This is 3 pi over 2. This doubles back to 2 pi. And then you can also write it without pi. So without pi, this, well, starts again as 0. This would be 3.14, and this would be 6.28. So in my experience, that's the thing that people mess up the most is the without the pi. Just think all the way around your circle is 2 pi, and pi is 3.14. So if I forget, I do 2 times 3.14, that's 6.28. And then halfway is just pi, which is 3.14. So it could ask you to draw some, well, I'll get to that one in the bottom. Let me just do them in order. So the first one says 135. Where's 135 degrees going to go? Which quadrant? Quadrant 2. Doesn't have to be perfect, but it is midway between 90 and 180. Okay, then goes for 540. Where's 540? Is 540 in between 0 and 360? Nope, it's too big, right? So I'm going to go all the way around my circle once. So if I did 540 minus 360, because that's what a coterminal would be, it's another 180, which means I'm going to come all the way back over here. That would be 540. So initial point is at 0, terminal point's at the 180, but I go around my circle one more time.
If we were to draw that, we could draw the little.
Yeah. We're eventually going to get trig values there. Then you don't need the circles, but to just draw it out, yeah. Okay, next up was what? 45. So 45 is in that first quadrant. It is halfway. Next up is 90. So that is at the top. Is that the last degrees? Yeah, okay. I'm going to redraw it so that we can clean it up. In terms of radians. So 0, pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to add on here 3.14 and 6.28. Okay, so what's next? 5 pi over 6. So for me, the easiest way to graph these without knowing the exact angles in between is figuring out what 5 over 6 is in terms of 1. So I ignore the pi just to figure that part out. Is 5 over 6 less than 1 or bigger than 1? Less than 1. Just a little bit less than 1, right? But it's bigger than a half, which would be at the top. At the top, this would be 1/2 pi, right? And this would be 1 pi. So 5/6 pi is going to be just close to the x-axis, right? Because it's almost 1. But not quite 1.
If we have the angle
You sure can. Yep, so if you convert it to degrees and you want to graph it, you sure can. It's just an extra step because you might not have to do that. Yep. All right, then what was next? 8, 3 pi over 4. So is 3 pi over 4, or 3/4. Is it in between 0 and a half, or is it in between a half and 1? Yep. So that one's in here, and it's halfway. 3 pi over 4. Number 9, negative pi over 2. What happens when it's negative? We go the other way, and if it's negative a half, where is it? Good, it's at the bottom. Okay, now 10 says 5. Now we're talking in terms of the without the pi, right? So 0 is on the right, 3.14 is on the left, 6.28 is on the right. Good. It's going to be quadrant 4.
If it said 5 pi, would that mean that you go around?
So 5 pi would actually end up on the left-hand side. I'd go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So odd whole numbers are on the left, even whole numbers are on the right. So this is 5. And last one is 2. Where's 2? Good, in quadrant 2. And I know it's not in quadrant 1 because this is half of 3.14. So that half is like a 1.6-ish, okay? So I know it's a little bit bigger than that. Let me get a different color. So for me, when it gets to the radians, like that whole numbers, if it's super confusing, then I take my circle, I do this is 0, this is 3.14, this would be back around to 6.28. And then I draw like little lines. So about halfway, just less than 3.14 would obviously be 3. Extend out in the other direction, and that's going to be 6. And then if you take that 3 from 0 to 3 and divide it into 2 parts, that's 1, that's 2, extend them out. That actually would go into here. And again, it doesn't have to be perfect. This would be 5 and 4. So if you want to give yourself a little cheat sheet of the radians, you could always do that. Questions so far? All right, then we finish off with arc length and area of a sector. So arc length is like your circumference, but this time it's in terms of radians. So arc length is equal to theta times the radius, and theta has to be in degrees. So this little arc length will be an S. I call this formula SOAR, if you put it in that order, okay? The arc length equals theta times the radius. And then the area of the sector is like the piece of the pie. So the arc length is like the crust of the pie, just the little arc around the outside. And the area of the sector is like the whole piece of the pie. Like if it was a Trivial Pursuit little pie piece, what's the area of that whole thing? If it's a literal piece of your pie, what's the area of your whole piece of pie? Like a flat pie, like a pizza, okay? And then the area of the sector is 1/2 r squared times theta. But again, theta has to be in radians. So for a lot of these, the first thing you have to do is convert them into radians and then multiply them by using their formula. Yep. If you put this in, I don't know if you remember, but if you put this in terms of geometry, the arc length was the measure of the arc over 360 times 2 pi r. That was length. And then the area was the measure of the arc over 360 times pi r squared. So we just rearrange it to be in terms of radians. That's all. It's a different formula. Get you the same answer. All right, so this one says a circle has a radius of 18.2 centimeters. Find the arc length and the area of the sector with theta being 3 pi over 8. So the length and the area of the sector That could be in any order. I guess I wrote it in the other order on the other slide, right? Is it 1/2? Yeah, it doesn't matter. I just put that 1/2 at the beginning of the last time. Okay, so first is you have to make sure that theta is in radians. Is your theta in radians? Yes, so that part's done. All I have to do is multiply it times the radius for the arc length, so 3 pi over 8 times 18.2. Without a calculator, I would just multiply out the numerators, so I would do 18.2 times 3. 54.6 pi over 8. With a calculator, I would actually multiply that out. So 54.6 times pi divided by 8. And I get 21.44. Oh, let me look and see. It on the homework, it's 2 decimal places. So 2.44. You can, yeah. Honestly, without the calculator, because it's the area, it's going to happen. I'm not going to make you square decimals. You won't get the decimal within the fraction. You can't leave the decimal in the fraction, technically. Like, I would have had to get rid of this either way, like move that over and then reduce it. But
for on the quiz, if I just put like 54.6 pi over 8, yeah.
you shouldn't have a decimal. You won't have a decimal.
Oh.
Yeah. But on the homework, it says find the length of the arc, round your answer to 2 decimal places. So that's how you know to use a calculator. So that's number 9. Number 10 you don't need to, but number 9 does. All right, then area theta, which is 3 pi over 8, times 1/2, times the radius squared. And I can simplify this any way I want. So I could put the 1/2 in the 18.2. Oh, no, I have to square it first. Sorry, just kidding. I left off the squared. I have to do 18.2 times 18.2. So 3 pi over 8 times 1/2 times 331.24. Divide that by 2. Multiply, well, and at this point I would just multiply it straight across. So 3 times pi times 165.62 all over 8 is how I'm going to write it in. 3, and you could have done that straight from the other one without reducing by 1/2. 3 pi times 165.62 divided by 8, and I get 195.12. And this one would be centimeters squared. So you won't have to give the units on the quiz, and it's given to you on WebAssign. Just know that they would be either centimeters if it's length and centimeters squared if it's area. On your quiz, you won't have a calculator, but you won't be squaring the decimals. So we'll practice some of those tomorrow, like leaving them exact, because that's how your quiz will leave them. Questions on that one? All right, this one says the circle has a radius of 18.2 centimeters with theta being 144. Find the arc length and the area of the sector. So what's the difference between this one and the last one? Good, this is in degrees and not radians. So the first thing I have to do is convert it. So I'm going to take 144, multiply it times pi over 180. 2 goes into both of these. This would be 72, 90. 2 goes into both of those, 36, 45. All right, so from here I can reduce this one more time, right? So 9 goes into both of these. It would be 4 and 5. So this would be 4 pi over 5. And that's theta in radians. So then the length would be 4 pi over 5 times 18.2. So I'm going to keep it exact. I'm going to do 4 times 18.2. 72.8 pi over 5. If this was on the quiz, I'd have to get rid of the decimal. So I'd move this one place and one place. And it would look like that, because you wouldn't have a calculator. On the homework, it'll say to round to 2 decimal places. So I'm going to do 728 times pi divided by 50. And I get 45.74. And this would be centimeters. I could have done that from up here too. I could have just done 72.8 times pi divided by 50. So if you had the calculator, which you will in the, oh wait, 70, oh, it would have been divided by 5, not 50. Okay, then area, theta, 1/2 r squared. Theta is 4 pi over 5 times 1/2 times 18.2 squared. So we did the 18.2 squared already. I can go 2 into 4, and then I have to multiply these two out. 331.24 times 2, 662.48 pi over 5. If this was on the quiz, I'd keep it exact, so I'd move my decimal 2 places, okay? But with a calculator on the homework, it's going to say round it, so I'm going to do 662.48 pi divided by 5. 416.25, and this would be centimeters squared. So the biggest thing I would say is just watch this one to make sure that you don't forget to square it. Like, make sure you square it first before you do anything else. I can't cut that in half and then multiply it out. You have to square it first. Questions for me? Everybody's good? Okay, so you can do, I'm going to stop here. There's like 1-2 questions on the homework that if it throws you off, like 11 and 12, I think. Yeah, 11 and 12. If you want to skip for tonight, this assignment, again, like I said, is due on Wednesday, so you can skip 11 and 12. You can try them too. But you can skip 11 and 12 for tonight, and then tomorrow we'll talk a little bit about them. We'll practice more of the exact questions, and I'll give you a little bit of time in class to work on your assignment. So my advice is to get at least to that point, like get at least to 10 tonight so that you're not doing all of it tomorrow. It'll stress you out more. You can do 13 and 14 on your own too, but if you want to hold off, that's fine too. Everybody's good? Yeah, okay. Natalie, I moved the